Hello there, this is the third video in the Fluent Validation series. In the last video, I gave you just a quick overview of our test application that we're going to use for exploring validations. Now in this one, we're really going to dig into it, and we're going to do two things. First, we're actually going to look at the business rules, the things that we're going to validate, and then I'm going to take a quick look at SQL validations, which is a way you can do some of these on the back end. So we haven't quite yet gotten to the actual Fluent validation library. And I'm excited to say that I've got an assistant to help me today. I've brought Dobby along. And Dobby is going to chime in now and again and give me some of his opinions on whether these techniques are good or not. So Dobby, are you ready to look into some validations?
Yes, Dobby is ready, sir.
Very good. I don't know if my voice is quite squeaky enough, but we'll make do. Okay, so here we go, diving into some of the details of business rules and SQL validation. So here I've got a little notepad document called Loan System Rules. And in it, I'm listing out the 10 business rules that govern our simple loan system. The first 3 rules have to do with the customer SSN field. This field is required, it must be unique, and it must match the 3-digit, 2-digit, 4-digit pattern of US-based Social Security numbers. Next, I have some rules for customer name. It's required, it has a maximum length of 100 characters, and it can only contain letters, spaces, and dashes. Last, we have a few rules related to the loans. Loan amounts must be greater than 0. The field has 10 total digits and 2 decimals, so we can't loan thousandths of pennies or $10 billion. Loans can only be made to approved customers, and a customer's aggregate loan amount cannot exceed $5,000. So if we make multiple loans to one person, they can't add up to more than $5,000. So those are the rules. Dobby, are you still here?
Yes, sir.
Are those clear rules?
Yes, very clear. Very good rules, sir.
Okay. So one thing that I want to talk about is how we can enforce some of these rules in our SQL database. And what I mean here is if you look at our architecture diagram, right down here in the SQL database, when we define the tables that make up that database, we can add rules, constraints, that will keep garbage data from going in. And I've done just that. So this is a file called create_loan_sys_tables.sql. It's a SQL script that I used to create both the customer and loan tables. And you can see how I've constrained it. First of all, the Social Security field is marked as primary key, not null, and there's a check constraint that prevents it from being the empty string. So taken together, that will make sure that the customer name is required and unique. Sorry, the SSN is required and unique. Customer name is set as varchar 100, not null, and there's a check constraint making sure that it's not the empty string. So that'll make sure the customer name has a value, it's required, and that the value can't exceed 100 characters. So that ought to take care of rules 1 and 2, as well as rules 4 and 5. Obviously, it doesn't do anything for rule 3 or rule 6. Looking at the loan table, the amount field is a decimal 10-2, not null, and there's a check constraint making sure that it's positive. So that should go some way to helping enforce rules 7 and 8, and it really doesn't do anything for rules 9 and 10. So what I want to do is run our CLI now. Actually, I should ask Dobby. Dobby, does that make sense? Good rules?
Yes, sir. Very good rules. Very good rules indeed.
Well, thank you, Dobby. So let's see about how these SQL constraints are going to play out.
Okay.
So what I'm going to do is I'm going to run the loan system CLI, and I'm going to run it not in the debugger, because this is going to generate some exceptions, and I don't want the debugger to halt. I just want the exceptions to flow on up and be displayed in the GUI. So let's break these rules, and I'm going to just kind of park this notepad document here. We can refer to it. So let's break our social security number rules. So we'll click 1 to add a customer. We're going to leave SSN blank and enter a name. And now what you see is we get a SQL check constraint error. So the statement was terminated. The insert did not happen. Let's break rule number 2. So we'll add a customer. And you may recall, actually, I need to go back and look. I think it was, yes, 111-22-3333 was the social security number we used before. We'll give it a name. And now we get a different SQL error, violation of the primary key constraint. So what about customer name? So let's add a customer name, and we can do another social security number. But now let's leave the customer name blank, and we hit our check constraint. So as you can see, SQL is doing a nice job enforcing these. Now, let's look at rule number 5. This one's a little interesting. So let's go ahead and add a customer. We're going to give it a social security number that's not been used before. And now I'm going to enter a name which is more than 100 characters, a lot more than 100 characters. So what we would like to have happen for consistency is that we get an exception that tells us that wasn't a legal name. Well, let's see if that's what happens. No, the customer was actually added. So what happened there? Let's go to our database and let's query. And what you can see is that SQL has simply truncated the value. So that's interesting. We now have 2 different behaviors. Sometimes the SQL constraints and table definitions cause exceptions. Sometimes we get silent truncation, which may not be a behavior you want. OK, so what other rules can we break? Let's break some loan rules here. So let's go ahead and let's enter 3 to make a loan. And let's make another loan to our first customer. And in this case, let's try to loan them -$25. I don't think that should work. Nope. Insert statement conflicted with the check constraint. So that was good. What about let's loan them an amount. Let's see, 111-22-3333. Let's loan them $50, but let's now create a lot of decimal points. So what do you think is going to happen here? Is it going to fail or is it going to truncate? So the loan was made, and what we can see is that it actually truncated the data. So it's the same pattern as we saw before. SQL is definitely enforcing this in terms of it's not letting us put more than 2 decimals in, but it's kind of happening silently, and the client really has no idea that the value they entered didn't really work. And this rule is being enforced. Now, one thing I do want to point out, again, that these other rules about the social security number pattern or the name rules and the aggregate amounts and all of that, none of that is being enforced right now. So watch this. Let's go ahead and let's do 1 to enter a customer. And for their social security number, I'm going to enter their social security number as ****. And for their name, I'm going to put it in as @. I'm going to just use some crazy special characters. This must be a celebrity. That's their name. And the customer is added. No problem at all. And we can execute that. And you can see our crazy customer has been entered. And now let's make a loan to that person. So we'll do that. And here's their ID. And we're going to make a loan for $10,000. And this is going to break 2 rules. It's a total aggregate loan portfolio over 5,000, and this person hasn't been approved yet. The loan is made, no problem. Okay, so as you can see, SQL validation works up to a point, but it has some issues. So Dobby,
Yes.
you want to help us critique this? What would you say is good about our approach of SQL validation?
Oh, well, what I like is that you really can't get around the rules. The database just protects itself.
All right, that's a good point. You know, because we are validating here at the storage level, at the SQL database, really, it doesn't matter how you're trying to put the data in. You're going to have a tough time getting around those rules. So that's good. Well, what are some of the things you don't like?
Well, mainly, it's not really enforcing all our rules.
Okay, this is a really good point. So as you can see, it's enforcing some rules, but not really letting us know that there was a problem. And in other cases, it's not enforcing them at all. Now, you may have noticed over here in my create loan tables file that I also created some stored procedures, which are used for data entry. And one can imagine writing these stored procedures in a way that started to enforce some of those other rules. For example, in the make loan procedure, you could query, select from the customer table and verify that their approval flag is set to 1, and then use raise error, or there are a couple ways you can try to do this out of SQL so that SQL validates it. And this would be if you were looking at an application written during in say 2008 or something like that. That's exactly how it would be done. There would be complex, rich stored procedures validating there. But that has really fallen out of favor. And the reason is that, one, SQL as a language, even though it does have procedural capabilities, just isn't nearly as literate and fluent as, say, C# for writing complex business logic. It is much more natural to write complex rules in something like the DLL. Also, it really ties you to your storage implementation. And what if you want to move to MariaDB or PostgreSQL or NoSQL or something else entirely, just a file database with XML files? Basically, you lose all of your business logic. So putting the validations here in the middle tier, or sometimes even a little further up, we'll talk about that, is really the industry standard approach. So my recommendation is when you're setting up a SQL database, go ahead and do some of the basic constraints. This is really a nice safety valve. It's good to constrain your database. Now, people will complain and say, oh, it makes loading data more difficult. Not really. You can, through bulk load and other tools, you can turn off the check constraints. However, you can't rely on SQL validations to do everything for you. And you really don't want those exceptions, those kind of awkward, unhelpful SQL messages propagating up through the UI. They're alarming to users. So now we're going to move on to actually validating at the middle tier in our library using the actual Fluent validation library. So Dobby,
Yes.
are you ready?
Yes. I can't wait.
Okay, we'll see you in the next video.